Fourth grade lesson 4.11 is dividing by one-digit numbers. Here we finally get to the point where you're using that standard algorithm for division that you'll use for the rest of the time you do math, if you have to do division by hand. And all of the other lessons just built up to this so that you know why we're taking the steps we're taking. So let's go ahead and see it all in action. Okay, our essential question is, how can you divide multi-digit numbers and check your answers? Let's unlock the problem. We have students in 3rd, 4th, and 5th grades making 525 origami animals, oh so cute, to display in the library. Each grade made the same number of animals. How many animals did each grade make? All right, well, we need to kind of look through at the information. Well, we know we need to underline the question. How many animals did each grade make? Circle information. We have 3rd grade, 4th grade, and 5th grades. How many, we can ask ourselves, how many grade levels is that? 3rd grade, 4th grade, and 5th grade? Right, that's 3 grade levels. And they made a total of 525 origami animals. We're taking that 525 that they all made together and splitting it equally into 3 groups to find out how many each of those 3 groups made. And you can see they told us that here, 525 being divided into 3 pieces, 525 being divided into 3 grades. Okay, we'll use place value to place the first digit. We're looking at the hundreds place in 525, or I guess we can look at it right here, 525. Remember, that's like the 5 flats. We're focusing on the flats only. We're focusing on 500. So we're going to go ahead and ask ourselves 3 times what number will get me as close to 5 as possible without going over 5? Well, 3 times 1 is 3, and 3 times 2 is 6, which is too much. I'm totally ignoring the 2, 5 right now. Just the 5, just the flats. So if 3 times 2 is too much, I can't use it. I'm going to do 3 times 1. And I'm only talking about the flats. So I'm going to put the 1 there in the hundreds place. And then I will write 3 times 1, which is here. I'm going to write the answer to the product to that there, 3. Because it tells me how many I've used of the flats. And then I can figure out how many are still left to deal with. 5 minus 3 is 2. There's still 2 flats to deal with. I would break them apart. And then I would bring down the 2 rods that are there. And you see here that the first digit of our quotient is in the hundreds place. That's where we'd have to put it because it was able to multiply together and get into at least once into the flat. So we divide the hundreds, and 3 times 1, of course, was 3. 5 minus 3 is 2. We share 5 hundreds equally amongst 3 groups. We multiply 3 times 1 equals 3. Subtract 5 minus 3. And 500 groups cannot be shared among 3 groups without some regrouping. We still have 2 left. We're going to have to regroup them. Okay, now we're going to look at that tens place. We brought down the tens. That's what they've done here. We regrouped those 2 flats into with the 2 tens rods, and that gives us 22 tens rods. And so now we're asking ourselves, we could either look at here or here, it's the same place. 3 times what number gets me as close to 22 as possible without going over? Well, I know 3 times 5 is 15. I could go more than that. 3 times 7 is 21. Ooh, okay, that's pretty close. And 3 times 8 is 24, and that's too much. So my goal, the game, is always as close as you can get without going over. It can be equal to, but it can't go over. So 3 times 7 is 21. That's as close as I'm getting. So I'm going to put the 7 up here. Remember, I told you guys knowing your multiplication facts will help you very much when we got to division, and I think you're now seeing that. And so if we have 3 times 7, that's 21. That's how many of them we used up of those rods. We're still going to have 1 rod left. 21 with 1 rod left. We're sharing 22 tens equally amongst 3 groups. We multiply 3 times 7. We subtract 22 minus 21. Okay. Now we're on the next part, and they've split it apart here, but the reason I'm showing you over here so you can see it all happen in one step. So now we're looking, we have one rod left. We will need to break it into pieces and put it together with our 5 ones. Okay. And we're sharing 15 ones equally amongst 3 groups. So we're going to ask ourselves, 3 times what number will get me as close to 15 as possible without going over? Oh, well, 3 times 5 is 15. Okay, that's exactly it. Ding, 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 ding. Win a chicken dinner. So 3 times 5 is 15. And I have none left. 3 times 5 is 15 with none left. So I multiply 3 times 5 to equal 15, and I subtract 15 minus 15, and there are 0 left. That means this is always your quotient. This part up here is your quotient. This means 3 times 175 will equal 525. And I could check that if I wanted to and calculate to make sure that I didn't make any errors. This means that each of the grade levels made 175. The 3rd graders made 175 origami animals. The 4th graders made 175, and the 5th graders made 175. The 3 different groups, each group made 175. That's how we got 525 total. Let's look at another example here. We have 8,523 sheets of origami paper that will be divided equally. When you see divided equally or shared equally, that's division, among 8 schools. How many sheets of origami paper will each school get? Well, what's being divided up? The sheets of paper. So that comes first this way, or it goes in the house, depending on how you're writing it. And into how many pieces is it being divided into? Into 8 schools. So 8,523 paper divided into 8 schools. 8,523 papers, that's what's being shared out or divided up and divided into 8 schools. And we're going to use place value to find the first digit. Notice, oh no, they gave us thousands now. Like, wow, okay, we're graduating up further. But it's all the same, so you don't have to stress out about it. I'll walk you right through it. We're going to ignore these, and we're just going to focus on the thousands place for now. 8 times what gives me 8? Right, 8 times 1 does. So we're just going to put that there. And what is 8 times 1? It is 8. So our first digit in the quotient will be in the thousands place. I'll put thous place. And will we have any of the thousands place left over? No. We divided the thousands place. Now let's divide the hundreds place. 8 times what equals 5? Nothing. Nothing, right? 8 times 1 is 8. That's already over. Too much, too much. It's really important that I say that, though. It's going to have to be 8 times 0. I can't just say, well, let's go on to the next one. Oh, well. I have to say, oh, it doesn't. 8 times 0 equals 5. So we're going to say 8 times 0 so that we know we need to break those up. 5 minus 0 is 5. We took care of the hundreds place. Now let's take care of the tens place. 8 times what number gets me as close to 52 as possible without going over? Well, okay, let's see. I know 8 times 6 is 48. 8 times 7 is 56, which is too high. I need it to be 52 or less. So it looks like it's going to be 8 times 6, 48. 8 times 6 is 48. Subtract to find out how much is left over. Oh, no, don't forget you're borrowing. You know you have to borrow 2 minus 8 is not going to work. It's not going to work. So we need to borrow. That becomes a 12. That becomes a 4. 12 minus 8 is 4. And then, of course, 4 minus 4 is nothing. You can always check and make sure that this number, when you have subtracted to see what's left over, before you bring down anything, check and make sure that it is smaller than that. Because if this number is the same as or bigger than the divisor, you could have gone more, and you're not going to get the right answer. So it's always has to be less than what the divisor is. Okay, I have 4 tens rods left. Bring down the ones now. We did the tens, we're on the ones. 8 times what number gets me as close to 43 as possible without going over? 8 times 6 was 48, which is now too high. 8 times 5 is 40. That's as close as I can get. So I will do 8 times 5 is 40. And I will have 3 left. So I have a remainder of 3. So each school will get 1,065 sheets of origami paper. There will be 3 sheets left. I'm not sure what they're going to decide to do with them. Maybe 3 schools will get one extra page. Maybe they'll give it to the lady in the office so that she could take those 3 pages home to her own kids. I don't know what they're going to do with it. Who knows? Maybe they'll throw them away. Maybe they'll save them for next year. Anyways, there's 3 sheets left. You might start noticing that having graph paper might be helpful. I do have some in my classroom, so if you feel like the thing about division is it's important that it be kept nice and neat and all your place values are in the right spot, especially as you get older and you're starting to deal with the decimals on these. Those are coming up, dealing with division 2, and you want to make sure everything, not till a couple years from now, don't worry. You're going to want to make sure that everything is lined up just right. So if you're somebody who has trouble keeping things lined up nice and neat and correctly, then use graph paper. I've got some for you. Okay, another example. This is number 1 on your Sharon show. Ollie used 852 beads to make 4 bracelets. He put the same number of beads on each bracelet. Putting the same number of beads on each bracelet is your division sentence. How many beads does each bracelet have? Check your answer. So we'll divide first and then we will check over here. So we have 852 beads. It's being divided into 4 equal pieces. How many, let's look at the hundreds place first. 8 is what we're after. 4 times what number gets us as close to 8 as possible without going over? 4 times 2 does, because 4 times 2 is exactly 8. Oh, that's nice. How much will be left? None. Bring down the next, the tens place. 4 times what gets me as close to 5 as possible without going over? 4 times 1. That's it, because 4 times 2 is 8, and that's too high. So 4 times 1 is 4. So I'll put the 1 here. 4 times 1 is 4. But that leaves me with 1 left over. Bring down the ones column. That breaks that apart into a 12. 10 rod and 2 ones is 12. 4 times what gets me as close to 12 as possible without going over? Oh, well, 4 times 3 is 12. That is right on. Winner, winner, chicken dinner. 4 times 3 is 12. And I have none left over. When we check it, remember division is the inverse or the opposite of multiplication. So if I have 213, if I have 852 being split into 4 equal pieces, I'd have 213. That means if I take 213 and multiply it by 4, I better get this. And that's what they mean by checking it. So I'll take 213, multiply it by 4, and I sure hope I get 852, or else I did something wrong. 4 times 3 is 12. 4 times 1 is 4, plus 1 is 5, and 4 times 2 is 8. Cha-ching. I did. Everything's good. Okay, we're on number 2, divide and check. So we have 394 being divided by 2. And so I'm going to write it over here so I have not lots of room. 394, I'd write that backwards, but that's okay. 394 being divided by 2. I will ignore these other places and focus just on the hundreds place. And I'm looking at the 3. 2 times what number gets me as close to 3 as possible without going over? 2 times 1 does that. If I do 2 times 2, it's 4. That's too high. 2 times 1 is 2. That leaves me with 1 flat left over. 3 minus 2 is 1. Flats are those hundreds places, right? Let's go ahead. Let's check. Is the remainder, current remainder, less than our divisor? Sure is. Okay, good. Then I may keep going. Mother, may I? Yes, I may. Bring down your 9 tens, your 9 rods. Now I have 19. How many 2s? 2 times what number gets me as close to 19 as possible without going over? Well, 2 times 9 is 18, and 2 times 10 is 20. And in anyways, if you find yourself wanting to put a 10 up here, you know you've done something wrong. This algorithm makes everything 9 or below when you're calculating it out. So 2 times 9 is 18. 2 times 10 is too high. So we're going to do 2 times 9. That gives us 18. What's left? 9 minus 8 is 1. 1 minus 1 is none. Is my remainder, current remainder less than my divisor? Yes, good, okay. Keep going then. We'll bring the 4 ones down. 2 times what number gives me 14? 2 times 7 does that, right on the money. 2 times 7 is exactly 14, so I will have no remainder. This is saying that 394 divided by 2 is 197. That is the answer. Now, how do I check it? I'm going to take the 197 and multiply by 2 because multiplication is the inverse or the opposite of division, so it better work, right? So we'll do that. 2 times 7 is 14. 2 times 9 is 18 plus 1 is 19. 2 times 1 is 2 plus 1 is 3. And ding, 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 winna, winna, chicken dinner. I did it right. So my answer is 197. And this is how I got there. All right, let's try another. I suspect you might be ready for a pause and try it scenario. You're probably doing pretty well. So you can pause and try it, and then if you get stuck or if you get an answer, push play and we'll see what we've got. All right, I'm looking at just my hundreds place first, totally ignoring my tens and ones place. 8 is what I'm after. 2 times what number gets me as close as possible to 8 without going over? 2 times 4 is 8 exactly. So I'm going to use 2 times 4. That gives me 8, which means I've used all the flats. There's none left. Bring down that 0 rods. I can't just say, oh, there's nothing, so I go on to the next one. I actually have to think it through and put something here for that represents the tens place. So 2 times what number gives me 0? 2 times 0 does. I have to put that. I can't skip it. So 2 times 0 is 0. And of course, subtracting that is very easy. Bring down the 3. 2 times what number gets me as close to 3 as possible without going over? Just 2 times 1, because if I do 2 times 2 is 4, that's too much. So just 2 times 1. 2 times 1 is 2. And I'm left with 1 left over. I'll just call it remainder 1. So my answer is 401, remainder 1. How do I check it? Let's do 401 times 2. We get 2. 2 times 1 is 2. 2 times 0 is 0. 2 times 4 is 8. That's 802, not matching, right? But one more makes it matching. Remember our remainder 1 over there? That's the one more. So you add that 1 left over to that, and ding, ding, ding. There we got it. All right, let's try one more. Okay, on this one, we have 3,448 divided by 4. We will start in our biggest place value, the thousands place on this one, ignoring the hundreds, tens, and ones place completely. 4 times what number gives me 3? Well, nothing, right? 4 times 1 is 4. It's already too high. I just like to get myself in the habit of marking that spot so that I don't mess up. This helps me, especially as you get older in the upper grades and you're dealing with decimals. And then you can keep things nice and lined up without messing them up. So I highly advise that you go ahead and just say it. Put the 0 there. 4 times 0 is 0. Do the steps so your brain knows exactly what's going on. 3 minus 0 is 3. Bring down the 4. Okay. 4 times what number gets me as close to 34 as possible without going over? 4 times 8 is 32. 4 times 9 is 36. 36 is too high, so it's going to have to be 4 times 8. I put that right above the hundreds place because that's what I'm multiplying with. 8 times 4 is 32. Subtract to find out how many of those hundreds flats are left. 4 minus 2 is 2. 3 minus 3 is none. Check, is this current remainder less than my divisor? Yes. Oh, good, good, good. Keep going. It's like repeat. We can put the loop on it like we do when we're coding. Just keep doing those same steps. Repeat, repeat till it's done. 4 times what number is 24? Oh, 4 times 6 is 24. That is the tens place I'm multiplying, so that 6 has to go above the tens place. 4 times 6 is 24. 24 minus 24 is none. That definitely is smaller than my divisor. Good, good, good. Bring down the ones place. 4 times what number gives me 8? 4 times 2 gives me 8. We're in the ones place, so we can put it there. 8 minus 8 is 0. Ta-da! My answer is, it says 0, 862, but as you well know, we can now that we're finished doing the math, we can call it 862. I think you all are comfortable with that 0 dropping off there if it's not sandwiched in by another number. So 862 is the quotient, the answer to the division problem, to 3,448 divided by 4. So if I multiplied 862 times 4, I better get 3,448. If I don't, I've done something wrong. 4 times 2 is 8. 6 times 4 is 24. 4 times 8 is 32, plus 2 more, 34. I did it right. Division is the inverse or the opposite of multiplication. So you can always check it with its inverse property or its inverse calculation. All right, I think you've got this. I think you're ready. Go get it.